Check this out. I have two variables, x and y, both storing the number 5. Under each one, I've written a shorthand that adds 1 to the variable. The only difference is which side I put the plus plus on. Looks simple, right? But here's the catch. This change in position may not seem like a big deal, but depending on the context in which it's written, it can cause some serious problems. Don't believe me? Well, let's look at it in code. Here I have the exact same thing, x and y both storing the number 5, but this time I'm printing out x and y while adding 1 to it. If we save this program and run it, you'll see that our answers are actually 5 and 6, but we're still adding 1 to both of them. The only difference is which side that plus plus is on. So how did we get two different answers? Hey everyone, I'm Sophia. I'm a certified computer science tutor here to help you understand C++. Now in the last video, we learned how to print variables, and in this video, we are learning how to use variables in arithmetic operations. We'll be covering the basic arithmetic operators, the modulus operator, integer division, and of course, incrementing and decrementing. If you would like a free PDF cheat sheet created by me that goes over everything covered in this video, the link is down below in the description. This is perfect for students who need organized notes to study and review material later. Now let's get into the lesson. First things first, what are arithmetic operators? Well, arithmetic operators are symbols used to perform math operations on values. We have our basic ones, addition, subtraction, multiplication, and division. But we'll also learn about a fifth one called the modulus operator. The modulus operator will return the remainder after performing integer division. Let's do an example of each of these arithmetic operations. To start off, let's create two integer variables. For simplicity reasons, let's call them a and b, where a equals 5 and b equals 2. Now let's start with addition. I'll write a print statement, add some text telling us this is the addition result, and then do the operation. All I need to do the operation is the first variable I want to use, the symbol of the operator, in this case it's a plus sign, and then the second variable. Then I'm going to add an end line so that the result of each output will appear on a separate line. I'll save this and run the program. And the result of this program should be 7 because we are adding the values 5 and 2 together. Now let's do an example of each of the other operations. We'll start off with subtraction, and we'll write a print statement with the text subtraction, and this time it's our first variable a, the symbol we want to use, and our second variable, end with an end line, and let's do the other ones while we're at it. We have multiplication, writing text that says multiplication. This time it's a times b. And then we have division. Where it's a divided by b. With an end line, so that the result of each operation is on a separate line. Now let's save this and run the code. And you'll see that the results are 7 for addition, 3 for subtraction, 10 for multiplication, and 2 for division. But wait, 5 divided by 2 isn't 2, it's 2.5, right? And you are correct, but in C++ what we just did is called integer division. That means if both operands or both numbers are integers, your returned result will also be an integer. The decimal part gets completely discarded through a process called truncation. Notice how it's not rounding either. Even if the returned result was 2.9, the program would still return the number 2. With that explanation, let's go over the modulus operator now. Let's set it up the same way. We'll start with a print statement with text modulus, and we'll do a. Now the symbol for modulus operator is the percentage sign. Then we do b and our end line. Let's save this and run the code. And the result that's returned is 1. How did we get 1? Well, we just learned that through integer division, the decimal part is completely discarded through a process called truncation, and the modulus operator will return the remainder after integer division. So 2 went into 5 twice, and we're left with 1 as a remainder. So that's how we get 2 for integer division and 1 for the modulus operator. Now, if you're doing division and you want your result to contain a decimal, you have to make sure at least one of your numbers is a float or a double, like this. We'll say floating point division. We'll create a fourth variable, this time having it be a double, and we'll say 5.0. We'll write another print statement, floating point division, and we'll do D divided by B because B still equals 2. And we'll write an end line. We'll save it, and we'll run the program. And you'll see that by just changing that one value, we are now able to get decimals in our result. So the result of floating point division of 5.0 divided by 2 will give us 2.5. Now it's important to note that integer arithmetic is generally faster than floating point arithmetic, and it's simply because it's easier for the hardware to handle. Whole numbers are stored directly in the computer using binary. That means operations like addition, subtraction, multiplication, and division can be performed quickly and efficiently by the hardware. Integers also don't have rounding errors or precision loss. Floating point numbers, on the other hand, are stored using a special format called IEEE 754. This format includes a sign, an exponent, and a fraction. Because of all of this, the CPU has to do a lot more work, things like handling exponents, rounding, and normalizing. Because of this, floating point arithmetic is generally slower than integer arithmetic and is less precise. But when the numbers are this small, the difference in speed is minute, so you won't even notice. Now I want to talk about something called typecasting. Typecasting is the process of converting one data type into another. There are two types: implicit type conversion and explicit type conversion. Implicit type conversion is when C++ automatically converts one data type into another during an expression. Explicit type conversion is when we manually convert one data type into another. Let's start with an example of implicit type conversion. I'll create two variables, an integer called IA, which holds 10, where I stands for implicit, and a double IB, which holds 2.5. Now, if we add these variables together and store them in a variable called isum, so IA plus IB, and then we can use a print statement to print out the result of isum with an end line. We'll save that, and we'll run the code, and you'll see that our result is 12.5. Our result is a double even though one of the numbers was an integer to start off with. That's because the integer was upgraded automatically to the larger data type in order to perform the calculation, but we didn't do anything ourselves. So this is implicit type conversion. Now let's do an example of explicit type conversion where we convert the data type ourselves. Again, let's create two new integer variables, EC, which holds 7, and ED, which holds 2. Then we'll create a double variable called eResult, and we're going to change EC into a double data type divided by ED. Then we're going to print out this result. So we'll say explicit result and eResult with an end line. We'll save this and run the code, and our result should be 3.5. So this time we changed our integer variable into a double to perform the calculation so that our result would be in the form of a double data type. Now, as we just saw in these two examples, we can store the results of arithmetic operations in a variable. We can overwrite the value being stored, or we can update it. So overwriting means you set it equal to a number or an expression, and then you quote unquote reset it to a new value or expression. So here, sum first equals 7, a plus b or 5 plus 2 will equal 7, and then it equals 10 or 5 plus 5. But we can also add to an already existing value in a variable or updating it. So here I'm saying sum equals its current value plus 5. So right now, sum would equal 15. There's also a shorthand we can use that does the exact same thing. It's sum plus equals 5. This is a compound operator, and we can use it with all of the operators that we've learned today: addition, subtraction, multiplication, division, and the modulus operator. In case you were confused, here's another example. We have y equals y minus 2. So the shorthand would be y minus equals 2. They both do the exact same thing. They subtract 2 from the current value that y is holding. Now, if you're only incrementing a variable by 1, there's yet again another shorthand that you could use. I'll write a comment here that says incrementing a variable by 1. So the original one is x equals x plus 1. The first shorthand is x plus equals 1. The last shorthand, if you're only adding 1, is x plus plus or plus plus x. Now, there's a slight difference between these two. They both add 1, but there's a small difference to it that I'll explain in 1 second. The same thing goes if you're decrementing a variable by 1. The original one is y equals y minus 1. The first shorthand is y minus equals 1, and then we have y minus minus and minus minus y. Again, slight difference between the two, but I'll explain that in 1 second. So you can only use this last shorthand if you are incrementing or decrementing a variable by 1. If it's anything larger than 1, you will use that first shorthand. So now let's move on and understand the difference between x plus plus and plus plus x. These are called prefix and postfix increment or decrement operators. Basically, depending on where you put the plus plus or minus minus, either before or after the variable, it will change when the value is updated. So let's go over the prefix operator first. Plus plus variable and minus minus variable. When the increment and decrement operator are placed before the variable, that means the variable is updated first before the expression runs. Let's do an example of it. Let's create a variable, int x equals 5. Now, we're going to do a print statement with the text before. This is going to be before we updated, and we'll just print out the variable x with an end line. Then I'm going to write another print statement saying during, and this time we'll increment it, plus plus x with a new line. Now let's do a third print statement with the text after, just printing x again with a new line. So this should show what x is before we change it, while we are changing it, and after we have changed it. So let's save the program and run the code, and we get our result. So let's take a look at this. Our first line before, this gives us a result of 5. Now this is because we haven't changed x yet. X is still 5, and we're just printing out x. But now with our print statement of during, we get our variable is 6. Well, that's because we are doing a prefix operator. That means our variable is updated first before the expression runs. So that means x was updated to the value of 6 before it is printed out. And then our third print statement is just showing what value x is holding after we have updated it. Let's do another example of this. I'm going to comment out these 3 print statements, and I'm going to create a new variable, y equals plus plus x. So I'm going to create another print statement with the text x and just have the variable x, and then I'm going to do the same thing for y, printing out the variable y. I'm going to save this and run the code, and our results both show that x and y are holding the value of 6. So this means the value in x was updated before that value was also assigned to the variable y. Now let's go over the postfix operator. I'm going to comment out these lines again so that when we rerun the program with new print statements, there won't be any confusion. Now the postfix operator is variable plus plus or variable minus minus. So when the increment and decrement operator is placed after the variable, that means the variable will be used in the expression first, and then it's updated afterwards. So let's go through an example. We already have the variable x created, but I'm going to reset it so that it equals 5. And then I'm just going to copy these 3 lines from above, just to make it easier. Uncomment them, and instead of plus plus x, it'll be x plus plus. We can save this and run it. Again, this will show us the before, during, and after of this variable being updated. Now, once again, we have our before statement, which is 5. That's because we haven't altered 5 yet. X still equals 5 at the beginning of this process. But notice how our second print statement differs from the first time we ran this. This time it says x equals 5. Well, that's because in the postfix operator, the variable is used in the expression first before its variable is updated. So x is being printed out before it's being updated to the value of 6. Then our third print statement shows what the value of x is after the expression runs, which is 6. Let's do one more example. I'm going to comment out these print statements, and I'm going to create our y variable again and say x++ using that postfix operator. Then once again, just creating two print statements, printing out the values of x and y. Then I'm going to save it and run the code. And we get our new results. Now before, x and y both equaled 6, but here x is equal to 6 and y is equal to 5. Well, once again, that's because the value of x is assigned to the variable y before x is updated. And that wraps up our video learning about variables with arithmetic operations. In the next video, we're covering some basic string functions. Thanks for watching, and I'll see you in the next one.